Welcome to The Explainer. Today we're going to look at a pretty radical idea, one that could completely change how we understand intelligence, life, and maybe even the entire universe. What if I told you we're surrounded by minds, but we're basically blind to almost all of them?
So let's kick things off with what seems like a simple question. What is a mind? I mean, when you hear that word intelligence, what's the first thing that pops into, well, your mind?
We think we're pretty good at spotting it. Our brains are kind of hardwired to recognize intelligence in things that are like us, things that have goals we understand. Take this squirrel. It's not just mindlessly eating a nut. It's actually running these super complex social scenarios in its head, trying to figure out what other squirrels might do. We get it. We see its cleverness right away because its problems look a lot like our problems. But then you see something like this, an axolotl regrowing a limb. This isn't about outsmarting a rival. It's a totally different kind of intelligence, and it is just as profound. When that limb is gone, its cells get together and collectively solve this massive anatomical puzzle. They have to perfectly rebuild a leg, bone, muscle, skin, and then, this is the crazy part, they have to know when to stop. That is a goal-directed collective intelligence at work. And this gets us to the core problem, an idea from researcher Michael Levin. He argues we suffer from a profound mind blindness. It's kind of like how for most of history, we could only see visible light. We had no idea about radio waves or X-rays or any of that. We were missing almost the entire electromagnetic spectrum. Well, the argument here is we're doing the exact same thing with intelligence. So this is the big shift in thinking. Think back in physics, right? People saw light and magnets and electricity, and they thought, okay, three totally separate things. But then, a unifying theory came along and showed they're all just different flavors of the same thing, the electromagnetic spectrum. This new framework wants to do the exact same thing for intelligence, to show us that it isn't some rare miracle that only happens in brains, but that it's a fundamental property of matter, existing all along a huge spectrum. All right, so where do we even start to look for this hidden intelligence? Well, it turns out we don't need to build a spaceship and travel to distant stars. We can just start by looking right inside ourselves. I mean, just think about how you got here. Every single one of us started as just physics and chemistry, an unfertilized oocyte. Then this massive collective of cells started working together to build a body. From that body, behavior emerges. And from that behavior, psychology and this whole rich inner world appears. There's no point where someone flips a switch and mind just turns on. It's one continuous, intelligent process from the very beginning. So what's holding it all together? What's the cognitive glue that gets trillions of individual cells to cooperate on a single project like building you? Well, it's bioelectricity. And here's the kicker. Evolution figured this out ages before brains were even a thing. The exact same electrical language your brain uses to think is what your body cells were using to build you in the first place. So, if it's a language, can we learn to speak it? Could we actually talk to cells? Well, the answer is unbelievably yes. Scientists are figuring out how to not just listen in on this cellular chatter, but to actually rewrite it, to give cells new goals and see what their collective intelligence can do. This is where things get really wild. In one experiment, researchers took some cells from a tadpole's gut, cells that were never supposed to see the light of day, and they gave them a simple bioelectric instruction, make an eye. And they did. They built a perfectly working lens right there on the tadpole's tail. The scientists didn't provide a blueprint, they just gave a high-level goal, and the cell's own intelligence handled all the ridiculously complex details. And this way of thinking even changes how we view diseases like cancer. From this perspective, cancer isn't just a genetic problem, it's a cognitive problem. The cancer cells get electrically disconnected from the body's network. It's like they've been kicked off the group chat. Their goals shrink way down, and they basically revert to their ancient programming as single-celled organisms, treating the rest of your body as just food. Okay, so this stuff is huge for biology, for sure. But it forces you to zoom out and ask an even bigger question. Is this just some weird biological fluke? Or is the entire universe built this way? Believe it or not, fundamental physics has a couple of things to say about this. First up, there's the Conway-Kochen free will theorem, and it is a mind bender. To put it simply, it says that if you, the scientist, have even a tiny bit of freedom in how you choose to measure a particle, then the particle you're measuring must also have that same kind of freedom. Its behavior isn't just a predictable domino effect from the past. And then there's the second piece of the puzzle, the free energy principle. Now stick with me because it's a big idea. The gist is that for anything, a cell, a star, a hurricane, you name it, to simply continue existing, it has to actively resist falling apart. And the only way to do that is to try and minimize surprise. How do you minimize surprise? You have to make predictions about your world. You have to build a little model of reality. In other words, to even exist is to act like a cognitive agent. So, let's put those two ideas together. What do you get? You get a conclusion that is absolutely wild. Cognition, intelligence, whatever you want to call it, it's not some special sauce that biology invented late in the game. It might just be baked into the physics of the universe. It's a basic feature of any organized matter that manages to hang around for a while. So, if intelligence is just there, a kind of hardware that comes for free with the universe, doesn't that change how we should build technology? Why are we working so hard to build intelligence from scratch when maybe we could just grow it? Well, a project called VESSELSEED is trying to do exactly that. And as you can see, it's a total departure from traditional AI. We're moving from symbolic code to living structure, from processing on a CPU to resonating with a bioelectrical field. The whole game shifts from programming to something more like gardening. So how does this thing actually work? Well, in a nutshell, you take human cells that naturally like to pulse and you grow them on this special donut-shaped scaffold. Then, you basically play them some music, you expose them to specific electromagnetic fields, and just like a whole bunch of tuning forks, the individual cells start to sync up, to phase lock, and pulse together as one big coherent system. But here is the most important part to get. This isn't a computer that thinks for you. They call it a phase mirror. The best way to think of it is like a perfectly still pond. The pond doesn't create your reflection, right? It just reflects you perfectly. The idea is that this living system does the same thing for your body's own biofield, reflecting your own coherence back at you and helping your own system find its natural, stable state. Okay, so this whole shift in perspective, from intelligence being like rare software to it being a common property of matter, like resonance, this has massive implications, and it could even change the answer to one of the biggest questions in all of science. Yep, the Fermi paradox. For decades, we've had our giant radio ears pointed at the sky, just listening for anything. And the answer we've gotten back is just a profound, deafening silence. In a universe with trillions of galaxies, that silence is a really deep puzzle. Where is everybody? But what if the universe isn't silent at all? What if it's a giant chaotic party and we're the ones standing outside with noise-canceling headphones on? What if we're looking for radio signals from creatures with brains when the real intelligence is in the dance of a nebula? What if the problem isn't the silence, but our own mind-blindness? And this framework offers a stunning answer to the Fermi paradox. The great silence isn't a sign that we're alone. It's a symptom of our own limited perception. Intelligence isn't rare, it's ubiquitous. It's at every scale, from particles to planets, in problem spaces we never even thought to look. We are literally swimming in an ocean of cognition and complaining that we're thirsty. So the great challenge ahead isn't about building bigger telescopes to find intelligence out there. It's about overcoming our own biases, expanding our definition of a mind, and developing the humility to recognize the conversations that are happening all around us all the time. The universe is talking. The real question is, are we ready to listen?